Hello students, welcome to SOURAV search classes. Let's find some solutions to calculus of variations in integral equations in this particular class. See, the question goes like this. The resolvent kernel for the integral equation ux is equal to fx plus log 2 to x e to the t minus t dt to ut dt. U is a function of t. The limit goes from log 2 to x e to the t minus ut dt. Fx is your fx, and then what is the resolvent kernel is, he is trying to know from you that what is the resolvent kernel. Okay, so the resolvent kernel is 1. B1 is your resolvent kernel. Now how it is 1? Okay, let me go. Let's solve the problem and find out what is the resolvent kernel of its 1, why it is so. Okay, so you given ux is equal to fx plus log 2 to x e to the power t minus x ut dt. On comparing equation, equation 1 with ux is equal to fx plus lambda log 2 to the power x, we have kx t ut dt. Now put lambda is equal to 1 and k let km be the mth iterated kernel, be the mth iterated kernel. Then k1 comma xt is equal to kxt is equal to kxt and then km xt is equal to t to x dz. Okay, now we have reached up to here. M is equal to So from equation 2a and 3 we get putting m is equal to 2 in equation 4 and using equation 5 we get k2x comma t is equal to t to x kx comma z k1 z comma t dz equal to t to x e to the power z minus x dot e to the power t minus z dz. Then if we go ahead, we have e to the power t minus x, t to the x, t to up to x, and then you have dz. Next, putting m is equal to 3 equation 4 we get this is your e to the power t. You should not get confused. Let me write properly. So it's e to the power t minus x, and then you have, so e to the power t minus x is z minus t whole square by 2 t to x, okay, t to x, e to the power t minus x dot x minus t whole square, that's whole square, and that becomes your 2t. Now let's go ahead solving the problem. So this becomes your finally e to the power t minus x dot x minus t whole square by 2 factorial and so on. You need to observing equations 5, 6, and 7 etc. by mathematical induction by mathematical induction we have km x comma t is equal to e to the power t minus x dot x minus t m to m minus 1 divided by m minus 1 factorial where m minus 1 factorial m is equal to 1 comma 2 comma 3 so on. So that becomes your equation number 8. Now let's move ahead. Now by definition of resolvent, now let's come to the resolvent kernel. By definition resolvent kernel, you have resolvent kernel, we have by definition of resolvent kernel we have R x comma t is to lambda is equal to sigma m is equal to 1 to infinity lambda to the power m minus 1 into km x comma t is equal to m is equal to 1 to infinity km xt, that makes it sigma using equation 8. Now e to the power t minus x m is equal to 1 to infinity x minus t m minus 1 upon m minus 1 factorial. So e to the power t minus x into e to the power x minus t, and now that makes it e to the power 0, and that makes your value 1. The value of the resultant kernel is 1. Okay. The value of the resultant kernel is 1, so that becomes your 1. Thank you for watching our video.